iTip Technology Center.
Welcome once again to another edition of Conversation with our experts here at iTip Technology Center. Now that the holiday season is over, and with them trips with nature and natural environments, we at iTip have considered evaluating the impact that our activities can have on this environment. As we all know, beaches, mountains, or leisure spaces where festivals have been held usually end up with waste that we should know how to treat correctly. We can do this in our day-to-day lives by using recycling bins, giving products a second life, or picking up the waste that we see thrown away. Most of this waste is plastic, as we can see in our homes when the bag that fills up the fastest is always the plastic one. This happens because this material is present in many of our daily activities, from water bottles to the wrapping paper of the packages that arrive at our homes. Although all the plastic go to the same container, behind our actions, there is a separation process that allows each one to be differentiated by its nature. To talk about the different types of plastics and their current and future recycling technologies, today we speak with Julio Vidal, Doctor in Material Science. How are you, Julio? Welcome.
Hello there, thank you for having me.
Julio, earlier when we were speaking, you mentioned that these general plastics are not the only ones that are present in our daily lives. Could you explain to us in what other formats we can find them?
Yeah, it's a fact that, you have normal standard plastics, plastics that we all use in our everyday lives, as you were mentioning before, the packaging plastics with the bottles, water bottles, and so on. But there are many different kinds of plastics. When we are talking about the train sector, the automotive sector, or the construction, even the aeronautic or the wind blades turbine sector, they are using plastics in all those components. Not all, of course, but they are using plastics, and they are using specific plastics that have better performances and that allow them to improve the performance and allow us to travel and so on.
I understand that these components you have mentioned do not go into the regular bin. So how are these plastics managed?
Yeah, it's very different. As you can understand, the trains, the wind blades, or so on, they don't go or they don't end up in landfill so easily. So we can control the management of these parts. You don't have a train every day thrown away. So it's something different that we can control. And it's this control that allows us to take it for a moment and think about how we are going to manage this new waste. Here, for these materials, we have several technologies. The most common one, or the one that is now commercial, is the milling. Okay, you just mill, break down the material, and try to use it as reinforcement or in any other part. Also, we have, and there's a lot of market initiatives right now for pyrolysis, which means that you will burn down these materials and try to use through the fire, or through these high temperatures, you will separate the different components and try to revalorize all of them. Also, at lower tier levels, more into the lab, let's say, where we are working is on chemical approaches that will enable us also to separate and revalorize. And a new principle that is being worked in the scientific community is the use of enzymes. Okay, the use of these natural parts that we all have in our bodies to break down these materials, these plastics, these different plastics, and again separate all the components properly so that we can take all those plastics into the proper flows of material and recycle them as well as we can. Yeah.
And do you have some examples, a specific example on which you are applying these technologies that you're talking about?
Well, in IT, we are working in several projects in this sense. We have one project, for example, is the Holo Hubs, that is just tackling the problem that we have in our region with wind blade turbines. Okay, well, we don't have it. We will have it in the future. Those of you that are from here or have been nearby IT you can see plenty of wind turbine mills. So we have a lot of blades, and therefore in a few years we will start to take down all these materials. So we will have to manage. We are trying to come ahead and find a solution that will enable us to avoid any problem with all this waste management. And this is the specific example, the EOL Hubs project. But we have others in which we are at lower tier wells. We are also investigating and working on all of these specifics and technologies, how we can apply it. But I will say that EOLO is the one that is closer to the market right now, and that is providing a solution, also working with companies around the area, such as the airport, Teruel's airport, in which we collaborate to find a solution for our region and our close issue, or how we can solve this problem that we have at hand.
This that is already being carried out from my tips research lines. When do you estimate that it could begin to be applied outside of R&D?
As I mentioned, there are different technology readiness levels in each of the different technologies that I have mentioned. We work mainly on solvolysis and enzymes, and for the solvolysis process I will say that 5 to 10 years we should have availability of these technologies in the market. In fact, because in those times is when we expect all these blades to start coming down. For the enzymes, it will be longer times. There we are still quite in the lab scale, and therefore let's say 10, 15 years, something like that. But of course, this always depends on how lucky or how successful you are. Sometimes you have a breakthrough that allows you to speed up the process a lot. We are trying to find those, and through them we will achieve shorter times, but it's always difficult to give a time frame.
Okay, thank you very much for your time, Julio, for explaining these topics that we didn't know much about. From what you talk about, we see that they also have a great impact on the environment, and that to ensure clean nature spaces, it is necessary to develop and apply the technologies that we have mentioned and that we are working on, I think. Thanks so much for listening. Stay tuned.